sample data. I have here sample from the population. Okay. We need to collect the data. So, yun class, actually, pag nagre-research ka na, yan yung gagawin mo. You need to collect the data. It is either experimental, descriptive, exploratory research, so madaming klaseng research class. And last but not the least, we need to perform the calculation required for that given sa atin yung problem. So we have now the calculation for the statistical test, and last but not the least, you will now have your conclusion. If your given hypothesis or the null hypothesis or the alternative hypothesis is your kung true ba siya or no. Okay? So, magbavari yan. Usually, you have these three methods that are used to test hypotheses. So, what are those? So, we have the traditional method, the p-value method, and the confidence interval method. So, I will discuss this and I will tell you or explain this on how do we evaluate the different methods in testing the hypothesis. Okay, tatlo yan class. We have the traditional, the p-value, and the confidence interval. We will make use of the tables, okay, in solving the problems here in the, specifically to the hypothesis testing, kasi we have different tests that are aligned depending upon the given parameters, if it is independent or dependent variables. Okay. Ayan. So, balikan lang natin. So, what really is, ano nga ba ang statistical hypothesis? Okay? So, this is a conjecture about a population parameter. So, this may or may not be true. And you will undergo research. So, you have this, the statistical hypothesis. Actually, class, alam nyo na to, the two types of statistical hypothesis for each situation. We have the null hypothesis and the alternative hypothesis. What is the difference between the null hypothesis and the alternative hypothesis? Hey, so kadalasan makikita nyo yung null hypothesis natin. We often see the symbol used in null hypothesis. So, symbols like HO, okay? So, what is a null hypothesis? That is a statistical hypothesis that states that there is no difference. Take note, there is no, difference between a parameter. And there is no difference between a parameter and a specific value, or that there is no difference between the two parameters. Ayan. There is no difference between two parameters. So, parameters class are evaluated or in your research, you will be the one who will identify what is your parameters in that research. Okay? So, you will make use of your review of related lit to prove that there is, yun yung you will make use of that parameter that you have undergo or you have read in the review of related lit. Yun yung magiging base point mo kaya magkakaroon ka ng research. Okay? We have also the alternative hypothesis. Yan. This is H1 class. H1. Kadalasan H1. in your senior high, ano yung mga ginagamit yung statistical symbols, specifically to the null and the alternative hypothesis. Okay, in the alternative hypothesis class, that is a statistical hypothesis that states that there is an existence of a difference between parameters. So there is an existence, meron kang difference between the parameter. Or there is a difference between two parameters. Take note, difference between two parameters. Sa null hypothesis, there is no. Yan palagi yung sa ulo nyo. While in the alternative hypothesis, we make use of the there is a difference. Okay? Meron siyang difference. Okay? For example, we have this. In a situation 1, or the given situation, a medical researcher is interested in finding out whether a new medication will have any undesirable side effects. The researcher is particularly concerned with the pulse rate of the patients who take the medication. Will the pulse rate increase, decrease, or remain unchanged after a patient takes the medication? Okay. Take note, since the researcher knows the mean pulse for the population under the study, which is, ayan, for example daw, we have 82 beats per minute. So the hypothesis for this situation, in a given problem class, your null hypothesis class, ang pinagbabasehan natin is the mean. So there is no difference, okay? Remain unchanged, so that is equal to 82. The alternative hypothesis is not equal to 82. Okay? Kasi dito sinabi, increase, decrease, or remain unchanged. So not equal to 82. Bakit? Kasi may greater than, or less than dyan. Okay? Yan yung mga kadalasang symbol sa alternative hypothesis. Okay? So the null hypothesis specifies that the mean will remain unchanged. Okay? Take note of that. Yan yung palagi nating null hypothesis in this given problem. Okay? Mean will remain unchanged. Therefore, yung alternative hypothesis natin states that it will be different. Okay. In this given situation, this test is called a two-tailed test. Yeah. Two-tailed siya, class. Why? Because that is a term that will be formally defined later in the section. Okay, I will define it later for you. Okay, since the possible side effects of the medicine could be to raise or lower the pulse rate. Okay, so this is an example of a two-tailed test. Okay, while here in a situation B, for an example, a chemist invents an additive to increase the life of an automobile battery. If the mean life of the automobile battery without the additive is 36 months, then her hypotheses are like that. And take note, yung null hypothesis natin is always equal to that of the given mean in the problem. And the alternative hypothesis now, bakit now greater than? Okay. In this situation, the chemist is interested only in what? Increasing the lifetime of the batteries. So, since nakita niya dito, invest on to increase the life. Yan. So, may mga phrases wherein makikita nyo kung ano yung ginagamit niyang hypothesis, or I mean the symbol used in alternative hypothesis. So her alternative hypothesis is that the mean is greater than 36. Yan. So if we have the two-tailed test, then this falls under the, okay, right-tailed test. Okay. So since this is greater than, okay, right-tailed test yan. Since the interest is in an increase. While in the situation C, so take note, we have the different hypothesis testing common phrases. Take note of that, okay? In a situation C, a contractor wishes to lower heating bills by using a special type of insulation in houses. If the average of monthly heating bills is 75 US dollar, her hypothesis is about heating costs with the use of insulation are, yan. Always your null hypothesis is equal to the mean of that. And we have also the alternative hypothesis. Okay, class? So, saan na? Okay, take note that here, this falls under the left tail test. Okay? So, since the contractor is interested in lowering the heating cost. So, for further analysis or for further help in everyone, this is the different phrases that are usually used in analyzing or stating your alternative hypothesis in a given situation. If the problem involves is greater than, above, higher than, longer than, bigger than, or increased, this will fall under this. That is greater than. While if the phrases falls under the less than, below, lower than, ayan, shorter than, smaller than, or decreased or reduced, then this will fall under this. The less than, or this is the left-tailed, this is left-tailed test. This is left-tailed. While here, this is a right-tailed test. Yan. Bagal mong sulat ni ma'am dito sa laptop. This is a right test. Okay? Since in the problem, if it involves is equal to, the same as, has not changed from, is the same as, so that is equal. And if the problem involves not equal to, different from, has changed from, it is not the same as, so this will fall under the two-tailed test. Okay? The null and alternative hypothesis are stated together. So take note, the null hypothesis contains the equal sign as shown, where k represents a specific number or a specified number. So in a two-tailed test, okay, so we make use of this, the null hypothesis natin, HO or H0. Okay? We have the mean. Yan palagi yung ini-state natin. Okay. But in a two-tailed test, in the given problem, you will have now the alternative hypothesis not equal to. In a right-tailed test, then your symbol now is greater than. And in a left-tailed test, the symbol now is less than. So how can we So we need to practice. Okay? For example, this one. In letter A, so a researcher thinks that if expectant mothers use vitamin pills, the birth weight of the babies will increase. The average birth weight of the population is 8.6 pounds. So what is now the common phrase that you can see here in letter A? Sige nga. What phrase in letter A? Anyone? Ay, walang nakikinig kay ma'am. So take note, in letter A, class. Oh. In letter A, what is your answer? What is your answer, class? Class, in letter A, what is your answer? Wala? Anyone?
Ano po ulit yung tanong?
What is the test that you will undergo? In letter A, given that you have the common phrase, ano yung common phrase na makikita mo dun sa problem sa letter A?
Increase po, ma'am.
Okay. So when it is increasing, therefore, yung test na gagamitin mo is what?
Right tail test po.
Okay. So this is a right tail test. So thank you for answering. Isa lang ata estudyante kung nakikinig. Okay? So this is now a right tail test. Okay. So in writing your hypothesis or in stating your hypothesis, in the null hypothesis, that is the mean is always equal to the average birth of the population, which is 8.6 pounds. And we have now the alternative hypothesis, which is your mean. Since the problem or the researcher want to increase the birth weight of the baby, so take note that is now that will fall now under the category of a right tail test since greater than. Okay, and letter B. Can anyone read the problem or the situation in letter B? Wala, parang nakikinig sa akin. In letter B, class, what do you think? Please read the situation B. Anyone? Oh. Nobody's listening. Anyway, in situation B, class, take note that an engineer hypothesized that the mean number of defects can be decreased in the manufacturing process of compact disc by using robots instead of humans for certain tasks. So the mean number of defective discs is per 1,000 is 18. So, given sa atin yung mean number natin which is equal to 18 and the common here now is common phrase is decreased. So, therefore, this will fall under the less than and this is now so-called the left-tailed test. The left-tailed. Okay. In letter C, so given sa atin, a psychologist feels that playing soft music during a test will change the results of the test. The psychologist is not sure whether the grades will be higher or lower. So in the past, the mean score was 73. So take note, the hypothesis now is equal to 73 and we have now the test that falls under this is two-tailed test because of the phrases that you can see higher or lower. Okay? Okay, wala naman ata nakikinig kay ma'am. So, in letter A class, so this is how you represent your statistical distribution of means in the given problem. So, ano yung natin sa letter A? 82. I mean, this is an example of representation of the mean. For example, 82, if our null hypothesis is true, therefore, yung mean na makukuha natin. Okay? So, this is now the true and the false naman class. So, yung 82 natin, dito na. Magpo-fall na siya on the left side of the distribution. Okay? So, a statistical test uses the data obtained from a sample to make a decision about whether the null hypothesis should be rejected. So, the numerical value obtained from a statistical test is the test value. Okay, this is now the test value. So, how do we evaluate the situation where your null hypothesis is true? We have different error. We have type 1 error and error type 2. Okay? In hypothesis testing situation class, there are 4 possible outcomes. Okay? Why? Because in reality, the null hypothesis may or may not be true. And the decision is made to reject or not to reject it on the basis of the data obtained from the sample. So here is an example of a type 1 error wherein it occurs if you reject the null hypothesis. This is your hypothesis. You reject it, automatically ang tawag doon is error 1 or type 1, which is you reject the null hypothesis where in fact it is a true. Okay. So ang correct decision then class is you do not reject your null hypothesis when your null hypothesis is true. Another error class is you have your null hypothesis false. Okay. Type 2 error occurs if you do not reject the null hypothesis when it is false. Okay? So, ang correct decision dyan, class, i-reject mo pag false yung null hypothesis natin. But when you do not reject the HO and the HO is false, therefore, ang nagawa mong error is a type 2 error. For example, the hypothesis testing situation can be to a jury trial. In a jury trial, there are 4 possible outcomes. The defendant is either guilty or not guilty. Yan. So, he or she will be convicted or acquitted. So, yung hypothesis mo, the defendant is innocent. Okay? The defendant is not innocent is yung alternative hypothesis mo. So, the correct decision class here, so if you if the defendant is innocent, actually, and you do not reject the HO, automatically you fall under the correct decision. While if you reject the HO, automatically convicted siya, where in fact yung totoo naman talaga is innocent siya, so nag-commit ka ng type 1 error. Another one is, sabi mo yung alternative, yung null hypothesis natin is false, so not innocent siya. At the same time, you reject the null hypothesis na innocent siya. So that is called correct decision, Kasi na-reject mo. Ibig sabihin, na-convict mo siya, not innocent. As well as if you do not reject the HO, inacquit mo siya, at the same time, false naman na hindi siya not innocent, you will have now the type 2 error. Okay? So, in the level of significance, we move on to this is just the errors that you can encounter whether solving the different hypothesis testing. Okay. So here is now the level of significance. You all know this, the maximum probability of committing a type 1 error. Kaya papasok na si level of significance. So yung probability natin symbolizes as alpha, or the Greek alpha. And the P is the probability of the type 1 error is equal to alpha. And the probability of a type 2 error is symbolized by beta. So the type 2 error is beta. The probability of getting that is the beta. In the most hypothesis testing situation, beta can be easily computed. However, your alpha and beta are related in the decreasing one increases the other. So, magpo-fall na class yung statistician natin. Because of that error, we have now here, the statistician generally agree on using 3 arbitrary significance level. So this is now your 0.10, 0.05, and 0.001. So that is, if the null hypothesis is rejected, the probability of a type 1 error will be 10%, 5%, and 1%. Okay. Depending on which level of significance is used. Okay. So in hypothesis testing situation, the researcher decides what level of significance to use. It does not have to be 0.10, 0.05, 0.01 in that level. Okay, take note of that. So you can any level depending on the seriousness of type 1 error. So after the significant level is chosen, a critical value. So we will need to use again the table E in your book in Appendix C, okay? So you will make use of the table for a certain appropriate test, okay? The critical value determines the critical and the non-critical regions. We have now the critical region, diba? Alam na natin ito in the very first discussion. Finding the critical value, it separates the critical region from the non-critical region. We make use of the symbol CV in the critical value. If we have the critical value, we have now the critical region or the rejection region. So from this, you can conclude you can now decide what is your decision in a given hypothesis. So in the range of values of test, value that indicates that there is significant difference and the null hypothesis should be rejected. While in the non-critical region, that is the range of values, the test value that indicates the difference was probably due to the chance and that null hypothesis should not be rejected. Okay. So a one-tailed test indicates that the null hypothesis should be rejected when the test value is in critical region or one side of mean. A one-tailed test is either right-tailed or left-tailed test. test, depending on the direction of inequality of the alternative hypothesis. Okay? Excuse me. Balikan lang natin. In finding the critical value for a given significance level of 0.01, given sa atin, right tail test. Okay. Ano yung kukunin mo? So, take note, yung critical region natin is 0.01. So, the shaded portion of the distribution is the total area of that is 1. So, 1 minus 0.01, then we have 0.99. 0.99. So, find this area table as shown. So, yung critical region natin, class, is the alpha. Ayan, yung 0.01. From that, we will have now the critical values from table E. You have the closest to 0.99 is 0.99. 0.9901. So, paano natin yan nakuha? With that, the table E, ito class, Appendix C, so the cumulative standard normal distribution, ito siya class, the 0.991. So, i-add nyo lang yung critical value natin, 2.3 plus 0.03, we have 2.33. So, that is now your critical Z value. Bakit kailangan natin siya? In obtaining the critical value, specifically, the researcher must choose an alpha level. Ayan, ikaw mag-choose niya ng alpha level mo. In situation B, suppose that the researcher chose an alpha 001 or 1%. Then the researcher must find the Z value such that 1% of the area falls to the right of the Z value. Ayan. So, inulit lang dito. And from the left of that, left of the Z value as shown in the figure below. So, ayan. Pinakita ko na to. So, automatically, this is now an example of a right tail test. Okay. Yung critical region natin is on the right side. And this is now your non-critical region. Another example for a two-tail test. Okay. The null hypothesis should be rejected when the test value is either of the two critical regions. Ibig sabihin, class, pag nag-fall siya dito sa critical region, you should reject your null hypothesis. Okay? So, in a two-tail test class, your alpha is divided into 2 kasi two-tail test siya in both sides. You have that, so 0.05, and this is now your non-critical region from here to this one. Okay? Another example for a two-tail test niyan, makikita niyo sa kabila, this is now your shaded portion. This is the critical region on both sides, on both ends of the your distribution. Okay? So we have now the summary of having this hypothesis testing and the critical values. Yan, class, this is an example of a left tail test. So dito, class, yung shaded part niya, so that is now your critical region. While here now in the second figure, you have now you have now the critical region shaded on the right portion, and a two-tail test now is on the both ends of the distribution. So how do we find the critical values of for specific alpha values? So we make use of table A. Ayan. So alam niyo na to. Sabi ko, pag two-tail test, i-divide mo sa 2 para makuha mo yung corresponding Z value. If left tail, kukunin lang natin yung area equal to that alpha and will be on the left side of the mean. Ayan. So this is now your example. This is the standard distribution. Ayan. This is the table that you can use. For example, in getting that, using the table E and Appendix E, find the critical values for each situation. Draw the appropriate figure. Show the critical region. So, given sa atin, left tail test with an alpha of 0.01. Take note, pag left tail test, kung ano na yung alpha natin, hindi na tayo magma-minus, or we don't need to subtract it from the total area of the distribution, which is equal to 1. In the left tail test, automatically you have the 0.10. Hanapin nyo siya on the table E. Specific to table E. Yan o. Dito na siya. Yan. Table E, we have now the, hahanapin mo na yung specific value. Ayan. Ay, hindi class. Ayan. Sa table E. So, ano yung hahanapin mo? So, pinakamalapit sa 0.10 is ang pinakamalapit doon class is 0.010. After that, you have the negative of that. Negative of 1.2 plus 0.8, we have negative 1.28. So, that is now the critical value for that given left tail test. So, this is now your negative 1.28. Okay? Another example, if a two-tail test naman class, given sa atin yung alpha niya, which is 0.02. You need to divide it by 2. Bakit? Kasi two-tail test siya. Two-tail test on both sides. So, we have now 0.01. So, since sabi ko, you can make use of this, sa left tail muna tayo. Gamitin na natin ito, 0.01. Ayan. So, yung distribution natin, in 0.01, which is approximately 0.99, ayan, makikita natin that this falls under the negative kasi nandun naman talaga siya sa left side. Checking that, nandun naman talaga siya sa left side. We have 2.3 plus 0.03. We have now negative 2.33. Okay. So, yung sa kabila naman class, so tama yun, yung 2.33 natin. Dito naman ka sa left side kasi two-tailed siya. You have 0.01, but take note, sabi ko nga, if it falls under the right-tailed test, you need to subtract the area by the alpha. So, you have now 0.01, then the nearest value is 0.9901. Now, it will fall now under the critical value 2.3 plus 0.03, which is now, let me correct this. This is now positive. Positive. Positive 2.33. And as you can see in the figure. Okay? And for the right tail test, sabi ko nga kanina, just need to, for an example of this, we have the alpha of 0.05. The total area of the distribution is 1. You need just to subtract it and find the values there. Ayan, we have. So, hindi natin alam. 2.58 ang nakuha natin dito. Bakit 2.58? So, 2.57 and 2.58. Ayan. So, dalawa yan. So, which is which? Ano yung gagawin mo? So, find the area closest to the 1 minus alpha. Pag in the right tail test class, 9905. But wala naman dito. So, in between siya dito. The 9949 and 9951. The two values corresponding 0.9949 and 0.9951, there are positive 2.57 and positive 2.58. Since 0.9 is halfway, we make use of this positive 2.575. However, 2.58 is most often used. Okay, na-round off. So how do we solve now? That is class the traditional method. Okay, the traditional method wherein you will draw the normal distribution showing the right and the left critical region, and if two-tailed test, you have both sides, both ends of your standard normal or the normal distribution had the critical region. Okay, so what okay, take note in solving the traditional method. You need to state the hypothesis first. You need to identify your claim. If your claim is greater than or decreased by or just equal to that of a mean. So you have that the first step. You need to state the hypothesis and identify the claim. Second one, you have to find the critical values. How can you find the critical values? By using the appropriate table in Appendix C. We need to compute for the test value and make the decision to reject or not reject the null hypothesis, and after that we need to summarize the result. That is now the traditional method. Okay, so we move on to the z-test for a mean. And the z-test is a statistical test for the mean of population. It can be known as your n is less than or greater than 30. All right, so when the population is normally distributed, we have now the population standard deviation. So we make use of this. We have the z-test, which is equal to the mean, sample mean. This is sample mean minus the population mean. Okay? Divided by the population standard deviation over the sample size. And so we have now the test value. So how do we apply na natin to class the traditional method in finding the what we want to prove in a given sample or a given problem. First, we have this, and class tinuro ko na ba to? Di pa? Okay. So, a researcher reports that the average salary of assistant professor is more than, yan, take note, more than 42,000. So, the sample consists of 30 assistant prof and a mean salary of, ayan, 43,260. At a given significance level, which is 0.05, we need to test the claim that assistant professor earned more than 42,000 per year. So we have now the standard deviation of the population, which is given as 52,300. So the very first is we need to state the hypothesis. Ayan. So yung claim natin na una is we have the mean, the null hypothesis, the mean is just equal to that of the mean salary of that professor, assistant professor, which is 42,000. The claim now is in the problem, test the assistant prof earn more than. So we have the common phrase here, more than, so that will fall under the right tail test or greater than. So that is now your claim. In step 2, we need to find the critical values for a given alpha or the level of significance. So we need to test whether it falls under the right tail test or the critical value. And finding the critical value. So, ito quest na critical value, hahanapin nyo na lang ito sa table. Okay? Ayan. Plus, may nakikinig pa sa akin. Can you raise your hands if somebody is listening to me? Okay, I have 10, 16, plus 3. Okay, 18. Akala ko wala nakikinig sa akin. Okay. So, here, class. And I will make it slower. And yung sa critical value natin, class, yan, makukuha niyo to sa C value. I mean, sa table A or appendix. Okay? So, yun yung hahanapin yung critical Z value. Why? We need to compute for the test value and the critical value. Kasi doon tayo magkukonclude. After that, ito na class yung test value natin. So, this is now your test value. We have the C test, wherein this is now your mean salary that was given in the problem. The mean problem is 43,260 minus the mean that we want to test in the problem. Ito yung iti-test natin, the 42,000. Okay? So, minus of that, divided by the sample, I mean the standard deviation of the population, which is given in the problem. Okay? Divided by the number of the samples, which is given in the problem, which is 13. So, we have now positive 1.32. Okay. Ayan. So, nakuha na natin yung test value now. Since step 4, we need now to make a decision. Since the test value now is 1.32, which is less than the critical value. Ayan. Ito na, class. Yung nakuha natin, 1.32. Ayan. 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 Ayaw niya mag-zoom. So, na-compute natin, class, is 1.32. But yung sa table natin, in a given level of significance of 0.05, okay? Critical value natin is 1.65. Since this is a right-tailed test, dito, class, sa right side nyo yung critical region, if the test value, yung na-compute natin, class, ito, na test 1.32, nag-fall dito sa critical region, we need to reject. But since in the problem, na-compute natin is 1.32, yung 1.32 natin, does not fall on the critical or the rejection region. So, ano yung gagawin natin? So, we need to summarize or conclude. So, do not reject it. So, there is not enough evidence to support the claim. Ito, yung claim natin. That the assistant professor earned more than the average of that. Okay? Average more than, earn more on, I mean, we need to summarize the results. So, there is not evidence to prove, okay, yung claim natin that the assistant professor earned more on an average that is 32,000 per year. Okay? Ito yung claim natin. So, di natin i-reject to na null hypothesis natin. Okay? No evidence na that is the greater than. Okay, we move on to another example. So here's now an example of a two-tailed test. Take note that here we have an average cost for rehabilitation stroke victims given sa atin, the 24,672. And also another example, average cost of rehabilitation is different at a particular hospital. A researcher selects a random sample of 35 stroke victims at the hospital and finds that the average cost of their rehabilitation is 25,226. The standard deviation of the population is 3,251, and at a given level of significance, we have 0.01. Can it be concluded that the average cost of the stroke rehabilitation at a particular hospital is different from the 24,000? So, in stating the hypothesis, we need to identify we need to state our hypothesis, the null hypothesis, and we need to identify our claim. Since in the problem, given sa atin dito, okay, so ano yung pinapahanap natin? Different from. Yan, hindi niya sinabi. So, yung claim natin, that is equal to that. I mean, that is not equal to 24,672. That is the average cost for the rehabilitation for stroke victims. So, finding the critical values, pupunta ulit kayo dun sa table since this is a two-tailed test. So, pag mali na class yung pag-identify mo ng claim, if you are wrong in identifying your claim, therefore, mamamali na tayo doon. Pababa. Okay? Mamamali na yung step 2 natin. I mean, hindi pa naman sa step 2 or sa step 3. Yes. Yung step 2 pa lang class, mamamali na tayo. Pero sa step 3, pwede pang makuha. But in making your decision or making your conclusion, maapektuhan niya. Okay? So, we find out the critical values. We have now the level of significance at a given. We have 0.01. Since this is a two-tailed test, you need to divide it by 2. Yan. Divide mo ulit siya by 2. The level of significance. Okay? After that, we have the positive 2.58 and the negative 2.58. This is now classed your critical values based on the table. Okay. So, in finding the test value, so we have now the mean. So, in the problem, it was stated that the average cost of rehabilitation, ito, sa task class, is 25,226. And yung tinitest natin sa sample is the 24,672. Okay? Ito yung, ano yung ititest mo na mean natin. Okay? And we have now the standard deviation, which is 3251, which is given also in the problem, standard deviation of the population. And we have now the random sample of 35. Divided by the square root of that, then this is now the test value. Okay. Etong test value natin, class, elaborate natin siya or papakita natin siya sa step 4 natin. And, okay. So, when having that class, when making a decision class, so this is now your, eto class, makukuha mo in identifying whether your problem falls under a two-tailed test or a one-tailed test. It will be right or left-tailed test. Since the problem indicates that wala naman siyang common phrase na pinakita but different from that of the mean in the given problem. So, this will fall now into two-tailed test. So, kinuha mo natin yung critical region. This is now your critical region. And so, you have now, this is now your critical region. And ito class yung nakuha natin test value using the different values that are found in Z-test yung kinuha natin, which is 1.01. Okay. Yung 1.01 natin, andun siya sa, saan siya, class? Nagpo-fall siya dun sa non-critical region or yung do not reject. Okay? Pag ito class, pag nag-fall dito, halimbawa, yung nakuha natin is negative 2.7. Pag nag-fall dyan, automatically, i-reject natin yung HO. Okay, reject. But since hindi naman nag-fall, there is no, wala tayong basihan para i-reject yung hypothesis natin. Okay? So, in summarizing the results, so there is not enough evidence to support the claim that the average cost of rehabilitation at a particular hospital is different from the 24,670. Okay? So, next is, this is an example of, in concluding the given hypothesis class, we have this. In claiming that if our claim in alternative, null hypothesis, for example, natin, pag nag-fall siya sa rejection region class, we automatically reject the HO. So, ito yung kadalasan natin na sinasabi, there is enough evidence to reject the claim. Yan. For example, you do not reject the HO, then there is not evidence. Yan. So, not evidence to reject the claim. Same with null hypothesis, alternative hypothesis. So, if we reject the the HO, automatically, there is enough evidence to support. Ayan. So, take note of this, to support the claim. Sa unahan, reject the claim. When do not reject, ito naman class, there is not enough evidence to support the claim. Ayan. Dito class, reject the claim. Ayan. So, this is a simple process wherein you have to reject or claim you have to reject or do not reject the given null hypothesis. Okay. So, since yung sa example natin dito, nagpo-fall siya sa do not reject. Okay. So, there is not enough to support the claim. Ginamit niya dito yung claim natin na alternative hypothesis, yung H1 natin. There is not enough evidence to support the claim. Ayan, ito yung ginamit. Tama pa rin siya, class. Okay? There is not evidence to support the claim. Okay? So, pag-aralan nyo on how you conclude the given, for example, yan class, give it sa atin na yan. You need to study whether it will falls under the, make use of this notation if you have to reject the null hypothesis or do not reject the null hypothesis. Okay? So, this will be a big part of your research. So, whether you reject it or you do not reject it. Okay? If it support the claim or didn't support the claim. Okay? So, if that is the traditional method class. Okay, balikan ko, this is a traditional method of solving the hypothesis testing. You move on to the p-value method for hypothesis testing. Okay. Anong pinagkaiba niya class sa p-value? So this is now, p-value class is the probability value of the probability getting a sample statistic such as the mean and more extreme sample statistic in the direction of alternative hypothesis when the null hypothesis is true. Take note, the p-value or the probability value is the actual area under the standard number distribution curve representing the probability of a particular sample statistic or more extreme sample statistic occurring if the null hypothesis is true. So in solving the p-value class, same lang naman class in the traditional method, is just what is the difference? Nauuna dito yung pag-compute ng test value bago hahanapin si p-value. And yung step 1 to 4 and 5, pares lang naman with the traditional method. Okay, so we have now here the solving process in the p-value. So here's an example. Okay, so a researcher wishes to test the claim that the average tuition fees and at 4-year public school college is greater than. Yan. So may word ka, may common phrase kang greater than. This is now a right-tail test. 5,700. She selects a random sample of 36 4-year public colleges and find the mean to be 5,950. So the population of standard deviation now is 659. So is there evidence to support the claim at a given level of significance of 0.05? So you need to use the p-value method. So dinectate nito class na we'll make use of the p-value method. Okay. First, we need to state the hypothesis and identify the claim. First one, the null hypothesis natin is equal to the mean of that, which is 5,700. And the alternative hypothesis now, since the problem involves greater than, and greater than, we have now greater than ayan, we have greater than, excuse me. So this is now a right-tail test. Now, in the traditional method, the step 2 is to find the critical value. While here in the p-value class, we need to solve first the test value. So, makikita naman to sa problem, given naman sa atin, yung mean niya, 5,950. Yung tinitest natin is the 5,700. Excuse me. And we have the samples or the population standard deviation divided by the square root of the sample, which is given in the problem 36. So we have now here 2.28. Okay. And take note. So find the p-value. So this is now. So using the table A and appendix C. Yan. Find the corresponding area under the normal distribution. So gagamitin natin yung test value here in a probability value. So 2.28. After that, mahanap natin doon is 0.9987. Okay. We need to subtract this value from the area of 1 and to find the area in the right tail. Kasi nasa right tail siya. Dito siya class. Ayan. Dito yan. So, kukunin muna natin. Ang nakuha nating z-value is 2.28. Yan. 2.28. Ano man? 2.28. Ayan. So, dito siyang part. So, nakuha natin is 0. Ayan. So, hanggang dito yung class. From here to there, nakuha natin is 0.9. This is 0.998. Since this is a right-tailed test, yung isusubtract natin siya class sa area na 198. Ayan. So, isusubtract natin siya. Matitira. That is now your area. So, this is now class the area. Ayan. So, therefore, class, kung ano yung nakuha natin, siya na din yung p-value natin, which is 0.113. Ayan. So, what is the difference in concluding, in using the p-value in concluding the results? Okay. So, if the decision rule now when using a p-value or the probability value, if the p-value is less than or equal to the alpha, we reject the null hypothesis. If the p-value is greater than alpha, do not reject the null hypothesis. So here in the problem, what is now your, yan, balikan natin. So yung p-value natin, ano siya? Ano yung alpha natin? 0.05. Which is which? Yung p-value natin, mas malaki ba sa 0.05? No. So, yung p-value ba natin less than or equal to 0.05? So, therefore, this is less than class. So, i-reject natin si null hypothesis. Yan. Yung decision natin. We are rejecting our claim that is equal to that the average cost of tuition fees at a 4-year public college is equal to 5,700. Yeah. So this is now the decision rule when having a p-value. Ayan. So this is another one. So, mas madali-dali class. So, a researcher claims that the average wind speed in a certain city is 8 miles per hour. Sample of 32 days has an average wind speed of 8.2 miles per hour, and the standard deviation of the population is 0.6 miles per hour. At a given level of significance of 0.05, there is enough evidence to reject the claim. Use the p-value. So, we need to state first our claim. So, average wind speed natin is 8. And that is our claim. So, yung null hypothesis, the alternative hypothesis now is not equal to 8. So, computing for the test value. So, 8.2 minus 8. Yan. Kasi given sa atin yung average wind speed and the standard deviation of the population, which is 0.6 divided by the 32. Okay, so test value and finding the p-value using table E. Ayan. We have now here, pakakuha mo ng z-value natin, class. Pupuntan ka naman doon, 0.97. We need to subtract because this is a two-tailed test. Okay? Subtract ulit natin siya. So, 1 minus 0. So, this is now 0.0294. Since this is a two-tailed test, the error of 0.0294 must be doubled to get the p-value. Ayan. So, hindi na siya dinivide, but you need to multiply it. Okay? So, that is now your... Ayan. In making the decision, the decision is to not reject the null hypothesis. Ayan, kasi yung nakuha nating test value natin is point, ano yung area natin? Yung p-value natin, ayan, yes. But yung level of significance natin, ito, 0.025. Ay, wala. Ano pa i-erase? Ayan. So, nakuha natin class. This is your, ito class, given naman sa atin yung alpha, di ba? Divide by 2 kasi that is the rejection. Okay. Okay, so that is now your area. So that is your alpha. So there is not enough evidence to reject the claim and the average wind speed, that the average wind speed is 8 miles per hour. So this is now the general guidelines for the p-values. Ayan. If the p-value is less than or greater than 0.01, reject the null hypothesis. The difference is highly significant. Ayan. So, madami class. Open notes naman kayo when it comes to p-value. Okay? Finding the statistic of a given value. Okay? So, this is now your second method in hypothesis testing, the p-value. And last but not least, the t-test for mean. Okay? So, alam naman natin, this is a review on our very first discussion about t-test. So, the t-test distribution is similar to standard normal distribution. So, this is Bell-Shell symmetric about the mean, median, mode are equal to 0 that are located at the center of the distribution. The curve never touches the x-axis. So, the t-distribution class differs from the standard normal distribution in the following ways. So, binalikan lang natin that the variance is greater than 1, the t-distribution of a family curve based on the degree of freedom. So, papasok na dito class yung degree of freedom natin, as well as the sample sizes increases as the t-distribution approaches the normal distribution. In the t-test value class, ano lang magpapalit na class? You have now the same formula. Yan. Yung S natin, standard deviation yun. But here, the sample standard deviation na to class, papasok na yung degree of freedom. And kung kanina ginagamit natin is table E, we will make use now of table F. Okay. So, in finding the critical value, T value for an alpha, 0.05 with the degree of freedom of 16, considering that is a right-tailed test. Okay, so alam niyan, pag one-tailed test, yun yung gagamitin mo, 0.05. Excuse me. And given sa atin yung alpha, we have the degree of freedom automatically. This is now the critical T value. Okay? That is now the critical T value of the a specific in the given problem. Okay? So when you test hypothesis by using the t-test as well as the traditional method, you are following the same procedure as z-test, except that you are now using the table F. And we have now the degree of freedom. Sabi ko. So this is the table T distribution. So how do we compute for this? For example, a medical investigation claims that the average number of infections per year at the hospital in southwestern Pennsylvania is 16.3. A random sample of 10 weeks had a mean number of 17.7 infection. The sample standard deviation is 1.8, and there is enough evidence to reject the investigator's claim at given alpha. Since hindi naman sinabi sa problem, our claim now is yan, equal to 16.3. So the alternative hypothesis is not equal to 16.3. So papasok na dito kasi yung degree of freedom natin. Okay? We need to compute for the critical values of the t-test. Okay? 2.62 and negative 2.62. Bakit class? two-tailed siya, pupunta tayo sa distribution table. Ayan. Pupunta tayo sa distribution na two-tailed siya. We have 0.08 that is given in the problem. And yung degree of freedom, 9. So, makukuha na natin yung values na. Since this is a two-tailed test, that is positive and negative of that number. Okay. Degree of freedom, so the sample is 10 weeks. So, n minus 1, that is 9. That is now the degree of freedom, which is equal to 9. The test value is now, we have the t-test. So, yung sample mean natin, mean number, 17.7. And yung tinitest natin is 16.3. Divided by the sample standard deviation. So, z-test plus, that is the population standard deviation. While here in the t-test, that is the sample standard deviation. So that is now divided by the total number of samples. So we have 2.46. Okay. So in rejecting the, okay, as you can see, you have now the critical values, negative 2.262 and the positive 262. Okay. So nag-false yung test value natin. So that is now reject the null hypothesis. Nag-false siya sa rejection unit, automatically reject. So, when we are rejecting the HO, there is enough evidence to reject the claim that the average number of infection is 16. Okay? Ayan. So, class naman, pag pinaghalo na yung p-value and when using the t-test, so this is now an example of that. Ayan. Okay? So, given lahat sa atin, the 2.056, the sample size is 11, and the test is right-tail test. Okay. So, this is now yung test natin. Yung degree of freedom is 10, kasi 11, and 11 minus 1, that is 10. So, tama to class. This is 10. Ano yung pinapahanap? The test is a right-tail test. Okay. Right-tail test. Okay. So, ano yung binigay sa atin? Yung mismong value. Ayan. So, test value natin is 2.5.06 and so, duro-diretso na yan, class. You have now the test value. So, ang hahanapin natin na nag-fall dyan is itong dalawa. So, within the range to class, so you can make use class of this since the p-value would contain in an interval of 0.025 greater than or equal to the p-value 0.05. Okay, so pwede yan class dito sa paghanap sa p-value, pwede yon. Ayan. Ayan. Bakit hindi na-click? Yan. This means that the p-value is between 0.025 and 0.05. Yung alpha natin. If your alpha is per 0.05, you would reject the null hypothesis. Okay? Since the p-value is less than the 0.05. But if our alpha is 0.01, you would not reject the null hypothesis since the p-value is greater than 0.01. Actually, it is greater than 0.025. Okay? So that is now another example in finding the p-value in a given t-test. Okay. So students sometimes have difficulty deciding whether to use z-test or t-test. The rules are the same as those pertaining to confidence intervals. Ayan. So this is now the different parameters or condition kung ano yung gagamitin mo. If your population standard mean is known, use z-test and the variable must be normally distributed if n is greater than 30. If your population is unknown, then n is less than 30, use z-test. If your population standard deviation is unknown and n is greater than 30, use t-test. Okay. So you will make use of this if it is a yes or a no. Okay. Another example, for the proportion naman class, we have the z-test for proportion. Yan, minamadali lang na. So, same as with those of the first claims natin sa mga unang example. It's just that this is now percentage, okay? So, a dietitian claims that 60% of people are trying to avoid trans fats in their diet. So, she randomly selected 200 people and found that 128 people stated that they were trying to avoid trans fats in their diets at a given significance level of 0.05. Is there enough evidence to reject the dietitian claims? So first, we need to state the hypothesis and identify the claim. Given sa atin yung population, I mean, not now, but in percentage. So this will now fall under the proportion. Okay? So 60. So yung claim natin, this is now our claim. So yung alternative hypothesis natin is not equal to that of our claim. So P na class kasi yung test for proportion. Population proportion. Yan. Since we have the alpha 0.05, kukunin natin yung test value ng two-tailed na, which is 1.96. 1 point, positive or negative 1.96. So, computing the test value, hahanapin muna natin, ano to? This is now your proportion. Yan, sample proportion, which is x over n. Okay? Yung x natin, found that 128 people. Ayan. 128 divided by the total number of the people, 200. So, this is now 64. Yung percentage natin is 0.6. And 1 or minus of that is 0.4. Okay? So, finding for the z-test for proportion, we have na 0.64. Okay? 0.64 to class. Minus 0.60 divided by the PQ, 0.6 times 0.4 divided by the N. So, this is now your z-test for proportion. And given sa atin lahat, ito na class. So, ito na yung value natin na na-compute. This is the alpha. Na-divide natin sa dalawa. Okay, so, we summarize now the result. So, sabi dito, do not reject the null hypothesis since the test values falls outside the critical region as shown in the figure. So, we need to summarize the result if there is enough. So, there is not enough evidence to reject the claim that 60% of people are trying to avoid trans fat. Okay, so this is an example for the z-test proportion. And last but not the least, we have the chi-square. Okay, chi-square for variance. Okay, so if we have table E, F, in the first part, E is for the z-test, F is for the t-test, and table G is for the chi-square distribution. So find the critical values for the degree of freedom. Okay, class? Okay, wait lang. Nag-entertain muna si ma'am ng tanong. Okay? So, in finding the chi-square class, mas madali na lang to class. Yes, class, you will just always find the level of significance in the table as well as the degree of freedom. You automatically have now the critical value. Okay? So, in formula for the chi-square test class, for a given single variance, so we have now the chi-square is equal to n minus 1 times the sample variance over the population variance. Okay? So, the assumption for the chi-square test for a single variance, the sample must be randomly selected from the population. The population must be normally distributed for the variable under the study, and the observation must be independent one. Okay, binibilisan lang class ni ma'am kasi madami nang nakapilang tanong dito sa labas. Andito ako sa office. Okay, so an instructor wishes to see whether the variation in score of the 23 students in her class is less than. Okay, so palagi na kayo class ha. Kayo na palaging gagamit ng into your alternative hypothesis. Ikaw magde-determine if you have the left-tailed, right-tailed, or two-tailed test. So, given lahat sa ating class, we have the variance of the class, 198. Okay? Yan, less than daw. So, we have the population variance at a given alpha. So, in finding the critical value, this test is left-tailed. We have now the alpha, 0.05. So, since this is a left-tailed minus the 1, okay, magma-minus 1 tayo. Bakit kaya nag-minus 1 dito? 0.95. Okay? So, the degree of freedom now is n minus 1. So, 23 minus 1 is 22. Since the critical value of that is 12.338, so note that the critical region is on the left, as it is shown in the figure. So, this is now class your 0.05. We have now the chi-square distribution. Okay? So, we have now the test value, proper substitution, given lahat naman sa atin yung sample and the sample variance and the population variance. So, we have 19.3. Since the 19.3 class doesn't fall in the critical region, automatically, the decision is to not reject the null hypothesis. Okay, so there is not enough evidence to support the claim that the variation in the test scores of the instructor is less than the variation of the score of the population. Okay, wait lang. Ayan. So, this is now your chi-square. Ayan. Okay. So, this is the chi-square. You have the degree of freedom, 0.05. So, baliktad na dito, class. Hindi ka na magma-minus, automatically you have the left-tailed test. Okay. Right-tailed ka. Okay. Kaya pala nag-minus siya dito. Okay. So, this is now the chi-square, and this is, last but not the least, the p-value using the chi-square. So, hahanapin nyo lang, class, automatically pag right-tailed, hahanapin nyo lang to. The degree of freedom as well as yung values natin kung saan siya nagpo-fall. Yung chi-square natin siya. So, between siya dito. So, ito na yung magiging interval mo. Okay? Yan. So, alam ko madami kayong question. So, hindi to class isahan na madali makukuha nyo lahat, ha? Wala. Discard lang. So, hindi yan madalian na isahan lang class, ha? If you have that now, in your problem, in presenting the, and, okay class, so, if you have any question, just PM si Madam kasi I have a lot of things to do today. So, pag nag-solve nito class, you need to practice not just one problem, but 2, 3, 4, 5 to master the differences between the right-tailed, the two-tailed test, the one-tailed test. So, papasok dito yung mastery, opo, in using the table as well as yung table EFG. So, z-test, t-test, the z-test for proportion, and last but not least, the chi-square test. Okay? So, that's all for today, class. So, I hope naman alam na alam nyo na yan. So, hindi naman masyado mag-iigpit si ma'am dito sa EDA. But take note, dapat nagpapas kayo ng activities. Okay? Can I request everyone to open their camera? Para, 50 na. Yan. So, masyadong madali talaga yung class. Dinali-dali ni madam. Okay? So, if you have any question, PM si ma'am. Sino itong nagtatanong? Wait lang, madami ng inquiries class. Ayan.